Cambridge IGCSE Chemistry, Elements, Compounds and Mixtures. Cambridge IGCSE covers ideas on atoms and elements, compounds and formulae, and on mixtures, and I've thrown in a couple of exam-style problems to help reinforce the ideas. The simplest idea of an atom is that it is the smallest possible particle of an element. So what do we mean by small? Well, the radius of an atom is measured in nanometers. 1 billion nanometers make up 1 meter. So what would 1 nanometer be in meters? Can you work it out, please? Stop the lesson, come back to check when you are ready. Okay, so we're going to divide 1 by 1 billion. So we write that as 1 times 10 to the minus 9 meters. Now you are required to use that form. It's called standard form. So here's another little task. If the radius of an atom is closer to 0.1 nanometers, can you write that in meters? Stop, then restart when you're ready. Okay, 1 times 10 to the minus 10 meters. So we've mentioned an element already on the previous slide. It contains only one type of atom. So we have a relationship. Atoms are the smallest particle of an element. Elements contain only one type of atom. So it's a mutually inclusive definitions. Elements can occur as single atoms, as giant arrangements of many atoms, all of the same type, or as molecules, that is, combinations of a known number of atoms. So here would be a representation of an element as single atoms. We can have giant arrangements, perhaps as in a metal. We can have molecules, such as a ring of 8 sulfur atoms in a sulfur molecule. All of these three have one type of atom and are therefore representations of elements. There are 100 known elements, and they are of course listed in the periodic table. For instance, hydrogen, sodium, sulfur, argon, you'll be familiar with those. Each element, of course, has a unique symbol: hydrogen, sodium, sulfur, argon. Please note, each symbol starts with a capital letter. If there's a second letter, it is lowercase. So sodium, for instance, capital N, lowercase a. That is one symbol for one element, sodium. Here's an exercise using the periodic table. Complete this data table, so the element symbol and element name. Come back to check when you've completed it. Okay, so capital H for hydrogen, sodium Na, capital K for potassium, capital M lowercase g for magnesium, capital C for carbon, capital C lowercase l for chlorine, and Fe is of course iron. All of those element symbols and names need to be known. Compounds and their formulae. Compounds are composed of 2 or more different elements, chemically combined. So let's look at some named compounds: copper oxide, calcium chloride, sodium hydroxide. What elements are there present in the compound? Well, let's do the first one as an example. Copper oxide, we've got copper and oxygen. What are the other 2 elemental makeups for these named compounds? Stop the lesson and just make sure you can identify the elements. Okay, so to reveal, calcium chloride, easy one, calcium and chlorine. Not necessarily quite so easy. Sodium hydroxide, sodium, hydrogen, and oxygen. So hydroxide is a combination of hydrogen and oxygen, sodium obviously. Now, the point is that compounds are formed by chemical reactions, usually with the release of heat. So calcium and chlorine combine to make calcium chloride, and we would know that calcium chloride is a chemical compound because in forming calcium chloride, there's generally a release of heat energy. Secondly, the compound calcium chloride cannot be easily converted back into its element. So there's a couple of clear indications that calcium chloride is a compound. The release of heat on its formation and the lack of convertibility back to its elements. Now, a third point is that the formula of a compound is always the same. So let's take calcium chloride. The formula is always CaCl2, no matter the reaction in which it is formed. So calcium and chlorine make calcium chloride, CaCl2. But we can also make calcium chloride from reacting calcium oxide with hydrochloric acid. We get a second product, water. But the formula of calcium chloride is exactly the same in both reactions. The elements are said to combine in a fixed ratio, 1 calcium to 2 chlorines, 1 calcium to 2 chlorines. Calcium chloride never has any other ratio than 1 to 2 between calcium and chlorine. So that's our third descriptor of a compound. So looking at the formula for water, H2O, this means we've got 2 hydrogen atoms for every 1 oxygen atom in the compound. So the 2 for hydrogen is written as a subscript following the symbol. Oxygen, we don't bother to write a 1, we just write the symbol 1. So that 2 applies to the hydrogen. There are 2 hydrogen atoms. There's 1 oxygen atom. So if we look at carbon dioxide, we've got a carbon and 2 oxygens. Could you write the formula for carbon dioxide? Okay, so 1 carbon, 2 oxygens. The 2 oxygens we indicate as writing a subscript 2 after the oxygen symbol. So that 2 applies to the oxygen. We just write carbon as is just 1 carbon. So 2 oxygen atoms, 1 carbon, 2 oxygens, 1 carbon. So have a go at this exercise. I've done the first one. Here's hydrogen sulfate, H2SO4. Element number 1 is hydrogen. There's 2 hydrogens. Element number 2, sulfur, capital S. There's only 1 sulfur, but there's a subscript 4 following the symbol for oxygen, so there are 4 oxygens. Stop the lesson and complete the element analysis for each compound formula. Come back to check when you are ready. Okay, so 1 magnesium, 1 carbon, 3 oxygens. That 3 only applies to the oxygen. 2 lithiums and 1 oxygen. The 2 applies to the lithium. It's subscript and after lithium, so it applies to the lithium. And then a little bit more complex, we've got a bracket. Everything inside the bracket is multiplied by the 2, the subscript 2. So we have 2 oxygens and 2 hydrogens, 2 oxygens and 2 hydrogens, but the 2 does not multiply the magnesium. So we just have the 1 magnesium. Mixtures. So let's talk about mixtures. So if each coloured sphere represents a particular type of atom, we can see here we've got 1 type of atom. They're combined, but there's 1 type of atom. Here we've got combination of more than 1 type of atom. So on the right-hand side we have an element. On the left-hand box, we have a compound. That is, there is more than one type of atom chemically combined. Now, in the upper box, of course, we have a mixture. That is, we have more than one substance or more than one formula. We've got the element and the compound within the substance. Now, a characteristic of mixtures is that they are easy to separate into their components. So we've got here an element and a compound mixed together. Characteristic of that mixture is that it can be easily separated into the pure element and the pure compound. So here are a couple of review problems. Well, here is the first one. If each coloured circle represents a type of atom, which box contains elements? Stop the lesson, take your time, pick out the elements. Okay, so to talk you through it, well, only one type of atom present in A, and D, although the atoms are combined into a molecule, there's only one type of atom, so D is also an element. C has more than one type of atom combined, as does B. So mixtures contain two or more elements or compounds, but they're not chemically combined. That is, they can be easily separated. So here's the task. Here are 5 boxes. Which of those contain mixtures? Stop, come back when you've made your choices. Okay, so B has a mixture of different types of atom. C has a mixture of 2 types of compound, whereas A, each molecule has the same formula, so it's one substance. D, each molecule has the same formula, and E, we just have single atoms which are identical. So only B and C are mixtures in that they contain more than one type of substance, not chemically combined. So well done for finishing. If you want to do some practice questions, you'll find some, no doubt, in the end of chapter in your textbook. And if you prefer past paper questions, I suggest you go to Physics and Maths Tutor website. Nothing to do with me, just got all the past papers you could possibly want. If you found the lesson helpful, please recommend it to a friend. Please like, subscribe for updates on classes and exam tips.